when composition fails. So as you can imagine, when we're considering domains of composite functions and composite functions in general, not every two functions can be composed. And we can look at an example here where we can see where it would fail and why. So consider that f of x equals negative x squared and g of x equals the natural log of x. If we try to compose g of f of x, what's going to happen here is we're going to be plugging negative x squared into the natural log of x. So here, we'd end up with something that looked like this. Now, if your intuition is telling you that something is wrong, then you have a good intuition, because the natural log is not defined for 0 or negative numbers, and every single result we can get from x is going to be something negative. So there's no possible scenario where we could plug something in where we would get anything out. And if there's no values that we can get as outputs, then the composition has failed. However, we could compose f of g of x, because if we went in that direction, we would be plugging g into f, and then we would have negative natural log of x all squared. Here, the domain is going to be that x is greater than 0, but there are outputs that come from this function, and therefore it exists. So the composition g of f of x will not work because there are no possible outputs. However, f of g of x will. It's rare that a composition fails, but it does happen. Consider now decomposition of functions. We spent a lot of time talking about how we can take two functions and use them to compose a third function. Sometimes, however, we start with a composite function and we want to consider what could the original functions have been. Most times that we do this, there are many ways to decompose the function. However, we're looking for ones that feel obvious, and again, there's more than one right answer. So for number 9, let's try to decompose each of the following functions. We start with e to the 2x minus 3. Again, there's many ways to do this, but what I'm seeing is that if we let f of x be e to the x and g of x equal 2x minus 3, then f of g of x will give me e to the 2x minus 3. So I have found two functions that I can compose together to get the function given. So I've successfully decomposed it. Number 2, I have the square root of the natural log of x plus x. Here, if I let f of x equal the square root of x and g of x equal the natural log of x plus x, then f of g of x will give me the square root of the natural log of x plus x. So again, I found a way to successfully decompose this. It doesn't matter if I had picked f of x to be the square root of x or g of x to be the square root of x, as long as my final composition is placed in the right order. And again, there's more than one way that I could have done this. Let's try 2 more. So for number 3, I'm going to do something a little wild. I'm going to say f of x equals x to the 5th. G of x equals sine of x. And h of x equals x cubed minus 4. Now here, I've picked 3 different functions to compose. I could certainly find a decomposition using only 2 functions, but here, there are 3 different functions to me, and so I pulled them all out. So f of g of h of x means I'm plugging h into g, and then that whole thing into f. And so that will give me sine of x cubed minus 4 all to the 5th. So again, that's one way that I can decompose this. And again, many functions have multiple ways that you can successfully decompose them. Finally, number 4, if I let f of x equal 4x and g of x equals x to the 4th, then f of g of x will be 4x to the fourth. So that's one way. And just to give you an idea of a second way, because I know I keep saying there's multiple ways, consider now that f of x is going to equal x squared, and g of x is going to equal 2x squared. Then f of g of x will equal 2x squared squared, which equals 4x to the fourth. So again, there's no one right way to decompose it, but it's a good idea to start trying these, because we're going to come back to this in chapter 3 and look at what we can do with composition of functions. And being able to decompose a function will be a very valuable skill.